Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is Vitamath 17. This is actually my proof of the angle bisector theorem and some other concepts extended here. So here is the problem. Show that the square of the length of the angle bisector through vertex C, which is angle bisector is CD, and I'll denote that with L sub C. So L sub C square is equal to AB minus X times quantity C minus X, and that A over B equals X over C minus X, and that X equals BD, the length of the segment intercepted by the angle bisector on the opposite side of the triangle. So to help visualize this X here, so here is the triangle ABC. Opposite to vertex C is side C, remember that's AB. So these are the other sides. Opposite to A is side small a, opposite to B is small b. Then the angle C is originally, let us say, 2 theta. That's why this is the angle bisector L sub C, which divides angle C into two equal parts. That's why that's theta and that's also theta. And if BD is X, because the entire length of AB is C, so this should be C minus X. We note this as beta, this angle here as alpha, then this angle here as P. So therefore, this is 180 degrees minus P. And we note further that sine of P is equal to sine of its supplement. That is, sine of P equals sine of 180 degrees minus P. So for example, sine of 30 degrees is equal to sine of its supplement, which is 150 degrees, and that is 1/2. Sine of 50 degrees is equal to sine of 130 degrees. So I hope that you know that already. And that AB is equal to side C, the opposite of vertex C. So we form the ratio. This is supposedly sine law. Sine of theta as to sine of B. So sine theta as to sine of B. In this triangle, opposite of theta is X. So in this triangle also, sine of theta is sine of theta really. And the other angle is sine of 180 degrees minus P, which is also equal to sine of P. So remember, sine theta as to the side opposite it. So it is X over A, because opposite of sine of B is A. It's just like A as to sine of B equals X as to sine of theta. So it's the same ratio here. The ratio of sine theta and sine of B is equal to the ratio of corresponding opposite sides of these angles. So X over A, sine theta here, the opposite side is C minus X, and opposite of sine 180 degrees minus B, or sine of B itself, is B. So therefore, we cross multiply A as to B, which is this, A as to B, equals X as to C minus X. So we have shown one angle bisector theorem that this ratio is true. We then apply cosine law in this triangle here, which is opposite of theta. Let's define cosine theta. So x square equals L sub C square plus A square minus 2 L sub C times A cosine of theta. And I hope you know already cosine law and you master that. Then we form 2 L sub C cosine theta, and it is equal to L sub C square plus A square minus X square all over A, because we still have A here. Transfer this to the left, it becomes positive, then X squared to the right, so L sub C square plus A square minus X square all over A. So that's the value of 2 L sub C cosine theta from this triangle. Then from this triangle, opposite of theta is C minus X, so C minus X quantity square equals L sub C square plus b square minus 2 times L sub c times b cosine of theta. We then substitute the value of 2 L sub c cosine theta, which is equal to this, into this equation. Factor out b. So c minus x quantity square equals L sub c square plus b square minus b times the quantity L sub c square plus a square minus x square over a, which is the value of 2 L sub c cosine theta from that equation. We then cross multiply, so a times quantity c minus x square equals a L sub c square plus a b square minus b L sub c square minus a square b plus bx square, and that's the expansion. We then retain this a L sub c square and minus b L sub c square. We copy this, then transfer this to the right. So a L sub c square minus plus ab square minus b L sub c square minus a square b plus bx square minus a times c minus x 1 to d square equals 0. Then we group this, transfer all the other terms to the right. So we have a L sub c square minus b L sub c square equals a square b minus a b square minus bx square plus a times c minus x c minus x. So this is negative. When transferred to the right by additive inverse, it becomes positive, and we break this factor into c minus x, c minus x. We then factor out L sub c square. Then we'll have a minus b here equals ab quantity a minus b, then minus bx square. Then take note that this a times c minus x here is equal to bx from this equation. Take note, a times quantity c minus x, cross multiply. So that's a times c minus x equals bx. So we replace this by bx, and this is it. Then we copy L sub c square times a minus b equals ab times a minus b. Factor out negative bx. Then we'll have x minus quantity c minus x. So take note, this is negative bx times x, negative bx square, negative, negative, positive bx times c minus x. So that's the correct factoring. Then from this equation, a over b equals x over c minus x, we subtract 1 to both sides. So we have a over b minus 1. We also subtract 1 from the right side of the equation, x over c minus x minus 1. So this is simplified into a minus b over b, and this is simplified into x minus quantity c minus x over c minus x. Then we note that this is x minus quantity c minus x, which is this, and the equivalent of this one, is equal to quantity a minus b times c minus x all over b. So we replace this by quantity a minus b times c minus x over b. So x minus c minus x equals quantity a minus b times c minus x over b. We replace this factor here by this. So L sub c square times quantity a minus b equals ab times quantity a minus b minus bx times quantity a minus b c minus x over b. Take note that a minus b is common to all terms. So we can cancel a minus b as shown. And since we have here b and b, we also cancel b. Finally, we can now show that L sub c square is really ab minus x times c minus x. That is L sub c square equals ab minus x times c minus x. So that's the angle bisector theorem, and this is the way I prove it. So that's it, and I hope you can recall this formula or this formula from that angle bisector theorem. Now let's have perpendicular bisector. How to apply this? When we have perpendicular bisector, the this angle bisector becomes perpendicular bisector if this triangle is isosceles. So we have an isosceles triangle. This is the perpendicular bisector, which is also the angle bisector if that's an isosceles triangle, so that it is perpendicular to the opposite side and it bisects the opposite side. That is, if we call that x, that's A, that's B. So B is equal to A is equal to B, or B equals A, because this is an isosceles triangle, because the angle here is bisected. The opposite side is also bisected, so this is x, and C minus x is simply x. So that this angle bisector reduces by Pythagoras theorem, L sub C square equals hypotenuse square A square minus x square. So that is L sub C square equals AB, remember AB, AA, minus x times, because this is also x, so x minus x. Or simply, you just interpret that as this right triangle, so the square of this leg is equal to the square of the hypotenuse, which is A in this case, minus the square of the other leg, x square. So there's no need to memorize that and to worry about that, because that is true for this isosceles triangle. Then another way is, remember, for the altitude drawn through the to the 90-degree vertex, the altitude to the 90 degrees vertex, this is the right triangle and it is 90 degrees there. And let us say this is not the perpendicular bisector anymore, but we call this the altitude supposedly, but I'll just denote that by L sub C. But this is no longer applicable because the angle is not bisected. So if I call this beta, and that's 90 degrees, this is also this altitude is perpendicular to the opposite side of the 90-degree angle. If I call this beta, this is 90 degrees minus beta. So that means this must be beta because the angle between these legs is 90 degrees. So this is beta. So that this is 90 degrees minus beta from this right triangle. So we form tangent of beta, and if we call this x, the other leg is c minus x. So tangent beta is L sub c over x, and it is also equal to c minus x over L sub c. In other words, the angle L sub c is the mean proportion to the segment it cuts on the opposite side. So that is L sub c is equal to the square root of x times c minus x, or simply L sub c square equals x times c minus x. L sub c is the mean proportion between the segment it cuts on the opposite side. So tangent theta L sub c over x equals c minus x over L sub c. So L sub c square is x times c minus x. So same relation or formula. Other way is when we circumscribe a circle. Remember that if we reflect this right triangle about this hypotenuse, and we already did that, we have two intersecting chords. This is also L sub c. So L sub c times L sub c, the product of the segments of one chord equals the product of the segments of the other. So that is L sub c times L sub c equals x times c minus x. And the result is the same. L sub c square equals x times c minus x. So finally, if from analytic geometry, the product of perpendicular lines, the product of the slopes of perpendicular lines is -1. So if we denote the slope of this as, because this is positive, opposite over adjacent, L sub c over x, the slope of this line is the negative of L sub c over c minus x. That is m1 times m2 equals -1. m1 is L sub c over x, and m2 is negative L sub c over c minus x equals -1. So negative 1 over negative 1 is positive. So L sub c square equals x times c minus x times c minus x. So which is the same as that. So that's all, and I hope that you learned something from this video, and you can now prove angle bisector theorem.